Yes, so my name is Michał and I work at Visuality, but today I have a topic that is more focused on the soft topics and on the psychology. And before we start, I want to tell you a story. April 2019. Maybe you remember this time, electric scooters on the streets. In main European cities, there were mobile applications to rent a scooter and applications that enable you to drive by the scooter in the city. And I happen to be a part of the team in one of such applications. It was a startup company, and every week new developer was joining the team. Every month we were entering new markets, and new features needed to be delivered really, really fast. Besides that, the project was also hard. First of all, we had their microservices architecture, another trendy concept at the time. And we had about 20 different microservices, each developed by different team, each developed in different time zone, and they were connecting with each other in different ways. To make it more difficult, we used trunk-based development. If you are not familiar with this approach, it means you are committing directly to the main branch. You don't waste time on creating pull requests, because it means when you create a feature branch and a pull request, you need to wait until your code will be checked. It's a waste of money, especially in startup. So, yeah, this is how it truly worked. So it's better to just commit, see if the CI is green. If it's green, let's deploy it to test environment. If automatic tests are green, it's directly deployed to production. So you push to master, and in 20 minutes, your change is on production. If something fails, it means you need to fix it fast. And the last factor that makes it even more difficult, we were not writing our microservice in Ruby. At some point, we decided to use Golang, another very trendy language at the time. And we thought that this speed gain you have when you use Golang is much more beneficial than using the battle-tested Ruby. So we went with Golang. What can go wrong? So we worked on a feature. Our microservice was responsible for a feature called automation. The idea is very simple. If some conditions are met, some automatic process should happen in the system. For example, if a scooter is placed in the warehouse in the middle of the night, please enable the maintenance mode, and let's download the update for the scooter software. So here I am working on the feature for 1 or 2 weeks, and in the middle of the day, on Wednesday, my colleague is creating a final commit. I'm doing a quick code review of the code on my colleague's computer screen, and it looks fine. So he pushes to master. CI is green, all tests passed, so it's deployed to the test server, tests are green, and it's deployed to production. Fine, works. Time to go for lunch. While we were waiting in the queue for the kebab, we started noticing different traffic on Slack. Lots of messages indicating that something is wrong in the system. Slack messages quickly escalated into emails, and emails escalated even into phone call. So we needed to throw away the idea of going for lunch, and we needed to come back to office and see what is really wrong. Well, we quickly find out. Turns out that in one of the biggest European cities, I won't tell you the name of it, in one of the districts, all scooters immediately stopped. It was a disaster. And looks like our microservice and the very first automation that we just pushed to master caused the issue. We mitigated the situation very fast because we simply turned off the microservice and we started debugging. Of course, it was just one line of code that was wrong, if condition. So we quickly deployed the fix, and then we tested it, and then it worked. But the trust our client had in our team was lost, and the impact of the bug into the system was quite significant. So unfortunately, the project was soon gone. And why am I telling you this story? Because, well, we software engineers, we make mistakes all the time. And it's very important to handle them in a proper way. And my presentation is about exactly this topic. So let's start with a simple definition. What is a mistake? We all know it from our experience. This is some unintended result of your action, or sometimes of the lack of your action. In our case, automation is supposed to run in the middle of the night, but it ran in the middle of the day. The good or bad news is that everyone really do mistakes. Maybe you remember last year CrowdStrike update. Lots of Windows machines were unable to restart because of the software update. Healthcare facilities, banks, media, many systems were well affected by this mistake, and over 5,000 flights were cancelled due to this mistake. But some mistakes can be more serious. There are lots of research on the topic of the doctors' mistakes in hospitals, and some meta-analysis shows that there is 5% of chance that if you go to the hospital, you will be a victim of some preventable harm. A doctor mistake during a surgery, or a nurse will give you wrong pills. 5%. Or, speaking about mistakes, and by the way, at the end of my presentation, there will be links if you want to read about some of those topics more. Also, another hilarious or tragic mistake, probably the biggest scandal in British government history, post office software that was officially used by post offices was full of bugs. And when they realized that, they decided to hide it. Instead, they said that post office masters, so people who run post offices, were wrong. And for example, they were charged of some mistakes in accounting, resulting in many people losing their jobs, their reputation, and even some of them were sentenced to jail. And all of that because of faulty software. And we can list mistakes more and more, but it's not so interesting. It's obvious we do mistakes. What is much more interesting is how we react on mistakes, and especially when we realize that we were wrong. And exactly this question, how people differently react on mistakes, was stated by Leon Festinger in USA in 1950s. Leon Festinger was a cognitive psychologist, and he and his team wanted to investigate exactly this topic, how people perceive mistakes when they made them. But Festinger had quite a unique approach. He read in one of the newspapers that there is a cult. This is a cult in USA in 1950s. Makes sense, right? There is a cult, and the cult leader who says that there will be apocalypse in few months. But interestingly, cult leader said the exact date. So Festinger wanted to see how people will react when they see that apocalypse didn't come. He joined the cult and was there observing cultists in their life, and he was there in the middle of the night when the aliens were supposed to come and only cultists would survive and the rest of the world should be destroyed. Yeah, that was the vision of the cult leader. Of course, it didn't happen as far as I know. So how people reacted on this fact? they divided themselves into two groups. One of the group, smallest one, reacted with kinda facepalm. So you see that there should be apocalypse, but it didn't happen, so maybe it means I was a little stupid or naive believing in cult leader who said so. Let me just forget about this incident in my life and let's go back home. This is, well, natural behavior. But there was a second group, much, much bigger, including cult leader, who said completely opposite thing. No, we were not wrong, we were right. Apocalypse didn't come thanks to our prayers. We put lots of effort into being in the cult. Some people abandoned their families. They gave all the savings to the cult. And thanks to that, the earth was saved. And the trust people had in the cult leader was even deepened after this incident. And this behavior was named by Leon Festinger a cognitive dissonance. Probably you heard about this term, it's very famous, and there is a ton of researches on the topic. But what really is the cognitive dissonance? This is a mental discomfort we all feel when we see that reality doesn't match the expectations we have in our mind. For example, we expected that the apocalypse will happen and it didn't. And now I need to somehow resolve this mental discomfort in my mind. And we need to choose what we will believe, what we will trust, if we are going to follow our beliefs or if we are going to adjust to reality that just happened. Unfortunately, this decision is usually unconscious and very fast, and it depends on many factors, your experience, your personality, and most importantly, on how much you were involved in the task. So what are those options? The first one, the group with facepalm. You can simply admit that reality is right. Well, I am wrong and I made a mistake. I need to update what I'm thinking. Before I thought that cult leader is trustworthy. I thought that me being in the cult is a really good idea. But now I see, well, it wasn't true. I need to admit that I made a mistake. Of course, there is the second option, much more convenient, and we often choose this option unconsciously, which means, no, I won't adjust to reality. I will try to reshape the reality to my expectations. For example, the apocalypse didn't happen, but it doesn't mean I was right. I was wrong. I was right. And there are tons of examples of cognitive dissonance. I will have some links at the very end if you are more interested in this topic. And one of the most researched topics is how people who smoke perceive their smoking habit. Because nowadays everyone knows that smoking isn't a healthy habit. But you can solve this dissonance when you smoke and you read that it's not healthy. You have two ways to solve this dissonance. You can think, all right, let me adjust my behavior and let me stop smoking. It's not healthy for me. But you can choose the second option. Well, okay, it's not so healthy, but it has some benefits to me. It helps me to handle stress, for example. Or my uncle also smoked for the whole life and he lived so long. So maybe this research is not right. Another topic that is really deeply investigated when it comes to cognitive dissonance is doctors' mistakes and the mistakes that are made during surgeries. Because imagine you are a 20 years experienced professor and you make a surgery and you commit a really stupid mistake. It's really hard to admit that even though you are so experienced, you made such a small mistake, right? It's better to say that, no, it wasn't me, it was some external factors. Or doctors used to say there were complications. Or it can even happen to developers. When I don't want to write documentation, I'm not exactly saying that I don't like writing documentation. It's much safer to me to say my code is self-explanatory. I don't need to write documentation. So to conclude the topic of cognitive dissonance, the bad news is the more experienced you are, the more attached you are to the action, the harder it is for you to realize that you made a mistake. Because when you invested in something, invested the effort, time, it's hard to believe that even though you was able to make a mistake, it's easier to think about yourself in a positive light. So what we can do about it? I came up with 3 ideas how we can handle this situation and how to help ourselves in dealing with cognitive dissonance in a good, productive way. This is a proper mindset, the posture of the scientist, and shaping the proper culture in our teams. So let's start with the first element, growth mindset. This is another concept introduced by psychologists. Carol Dweck, another American psychologist, made a simple division that people either believe that your abilities are fixed, so you are born with talents, or you either believe that everything can be learned, everything can be trained. For example, in Poland and in European culture, we tend to think that math skills is something that you are born with. If you are in a primary school and you have bad grades, your parents probably will say, okay, I wasn't good at math either, so just try to survive the school, okay? You won't need math later on in your life that much. So this is the example of fixed mindset. You are bad at math and you cannot do anything about it. Sorry. On the other hand, as far as I know, in Asian culture, they have different approach. When you are bad at math, the parents will say, okay, you need to spend more time on learning math because everyone can learn a decent level of math. So you believe that you just need to put more effort. And why am I telling you about the mindset thing? Because it heavily influences on how you perceive errors. In fixed mindset, you want to avoid mistakes. Because if you are born with talents and you make a mistake, it's about you. Well, if I made a mistake, it means it's something wrong with me, and I cannot do much about it. So let me not do mistake, let me hide mistakes. In this mindset, we tend to look for easy tasks to prove our talents. On the other hand, in growth mindset, we want to look for challenges. And if we make a mistake, we just find one more place to improve, one more place that we can learn on. It also influences how we cooperate with others. In fixed mindset, we are used to comparing our skills to another people because, again, it's all about our personality, our talents that we are born with. On the other hand, in growth mindset, we perceive others as sources of learnings. We seek relationships with experts, for example, because experts are not threat to our self-esteem. They are a chance to learn something new. So a key takeaway here is try to embrace this growth mindset. And by the way, Carol Dweck, who is the author of this idea, also had many books on the parenting, because this growth mindset is really helpful when you want your children to learn. Second element, be a scientist. What I mean by that? We live in a complex place and mistakes happen, but another thing about this world being complex is that we are not always sure what will be results of our actions. So we need to take the posture of the ideal scientist and try things in practice. In software engineering, and especially in Ruby, we are naturally exposed to this approach because we usually use agile development. And the core idea here is to ship fast and get feedback from users fast. So see how it works in practice. Another element, if you are a scientist and you want to prove some theory, you are not looking for places when your theory works. You are looking for places when it doesn't work. Because to improve the theory, you need to invalidate it and find all the tiny places when it fails to improve the theory. And that's the same with the solutions that we are building as software engineers. And the last element, have a control group. Again, in science, it's natural and obvious that if you have a solution and you want to test its effectiveness, you need to compare it to the group where you are not using this solution. In software engineering, it's not so obvious, but again, we can use A/B testing, for example, for that. Or if we have a big problem that we are solving, we can try to divide it into smaller parts and apply different solutions for them, and then compare it. And also, I learned recently that there is even a gem in Ruby called Scientists that does exactly this. For example, it allows you to run the code in 2 different versions and then compare the results. And last element. This will be especially helpful if you are a team leader or a CEO or you lead any other team, because you want to make sure that the team you are building is a safe place to admit to mistakes. So it needs to be written in the culture of the team that anyone can make mistake and it's okay to share knowledge about them. For example, in Visuality, we have every week we have engineering meetings, and we share the challenges from the last week, interesting topics from the projects, success stories, but also mistake stories and the failures that we made, because we want to make sure that others can learn on our mistakes. And that's the second point. When you do that, and when you have a culture that is open to sharing mistakes and transforming them into learnings, make sure that you document them and make sure that the conclusions from the mistakes will be easily accessible and simple to understand. So even if a developer joins your team in 1 year, he or she will know what happened and how to understand the learning. For example, use technology you are familiar with when you work on a client's project. And embrace the elements from the previous factors. So try to use the growth mindset approach. For example, if you see that your teammate put a lot of effort in some task, but at the end it failed, it's still a good moment to prize this effort because there was lots of work put into it. Or try to look as a scientist and make sure your team also works in a manner of experiments. And personally, I think this is very helpful in a communication with client. For example, if you have a hard to debug problem on production, you can tell that, all right, we are not sure how to reproduce it, for example, and we have few ideas how to solve it, but let's treat it as experiments, which means your first or second try might not be successful, and this is okay. Whoa, so yeah, going to the end of the presentation, before I finish, I want to tell you a story. April 2019, electric scooters in European cities. You know the story. So let me quickly recap that there was many difficult factors in it. Microservice architecture, trunk-based development, Golang, not Ruby, and it all ended as disaster. But maybe you noticed that I didn't explicitly say what was wrong on our side and what exact mistakes we made. So let's try to figure out. First obvious mistake was that, well, we participated in a decision to use Golang, not Ruby. We wanted to try a new language, very trendy language at the time, and yeah, let's be honest. A client's project is not a good place for developers to play with new toys, right? The conclusion is simple: use the technology you know. Another element, we used trunk-based development, and we didn't figure out the efficient way of doing code reviews. We were used to checking PRs, and when there is no pull request and you need to check your colleague's code commit by commit, it was very hard and ineffective for us. So the learning is also simple. Put more effort into taking care of code quality. But probably the most serious error we made there was lack of business context. There were tons of microservices and we didn't have the full picture on how the system works. And we were surprised that the feature we just released was turned on from the very beginning. If we would have known that, probably we would schedule the deployment in the evening hours, for example. So again, learning is pretty easy. We should understand the impact of our features on the whole business. So to sum up, I hope that after my presentation you will perceive mistakes as not a threat to you, to your career, to your personality, but as a learning opportunity. And maybe you will be more aware of the cognitive dissonance that is happening to you. If you want to read more about these topics, I highly recommend you those 3 books. There will be links. Yeah, there is a link on my page. And thank you.